Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Aldehydes, Ketones and Carboxylic acids. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. And also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. And also some important homework questions on every chapter of chemistry will be uploaded on in the Sapience Education application, which are based on the previous year KCET exam. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that the compound on hydrogenation gives a ketone. The original compound is. So the rule is that a 2-degree alcohol, or I can say a secondary alcohol on dehydrogenation, on dehydrogenation gives gives a ketone. For example, if we have RCHOH and here R dash, which is a 2-degree alcohol. So here we have two alkyl groups which are attached to this carbon. So obviously it is a 2-degree alcohol. So here if we react it with copper in the presence of heat at 300°C, then it will form a ketone. Ketone will be formed and it will remove, and one hydrogen will be removed. So it means that it should be a secondary alcohol. So option D is the correct answer. Then it is told which of the following organic compounds answers to both iodoform test and Felling's test. So if we take ethanol, or acetaldehyde, which is CH3CHO, then it will give a red precipitate with Felling's solution. Since why? This CH3CHO, it reacts with cupric hydroxide solution, which is called the Felling's solution, in the presence of sodium hydroxide. Then it will form CH3COO Na, which is the sodium acetate. Then it will form cuprous oxide, which will form a red precipitate and H2O. So it gives red precipitate with Felling's solution, and also CH3CHO will react with the um, with with an alkaline solution of iodine, which is I2 and 4NaOH. So it is an alkaline solution of iodine, which is used in the test. Iodoform test. Since why here iodoform will be formed, which is CHI3, which is a yellow precipitate. Yellow precipitate of iodoform will be formed, and then sodium methanoate will be formed, HCONA, and 3H2O and 3NaI, sodium iodide. So, so it means that it will give the iodoform test also, and it will give the Felling's test also. So hence ethanol is the correct answer. So option A is the answer. Then waxes are esters of. So waxes actually they are esters of long chain saturated fatty acids and long chain saturated and unsaturated fatty acids with with long chain monohydroxy alcohols with long chain monohydroxy alcohols. So they are the e- esters. It means it is of the form R dash COOR. So it is in the form of esters which are formed from long chain saturated and unsaturated fatty acids. It means that RCOH, which is a fatty acid, and which should be long chain. It means this alkyl group should be a very long carbon chain, and it will react with monohydroxy alcohols. It means with ROH, and this alcohol should be monohydroxy alcohol. Then only if they react, then this kind of ester will be formed, which will be called as wax. So they are formed from long chain alcohols and long chain fatty acids. So option B is the correct answer. Then here CH3COH, which is the acetic acid that reacts with lithium aluminum hydride to form the compound X, and this compound X will be nothing but the ethanol. X is the compound X is the ethanol which will be formed. The lithium aluminum hydride, it gives hydride ion. It gives hydride ion which will act as a nucleophile. So then it will react with copper in 300 degree Celsius. Then it will produce CH3CHO. So since why from 1 degree al alcohol we will obtain the aldehyde. Aldehyde will be formed. Since why when copper is used, it will remove one molecule of H2O. It will remove H2O, then mm, no, it will remove only H2, and then aldehyde will be formed. So it is a kind of dehydration. No, it is dehydrogenation reaction. And then this CH3CHO is the compound Y, which is the ethanol. Then it is reacting with dilute NaOH to form an alcohol, which will be CH3COH. CH3CHOH and CH2CHO. So it is the compound Z. So this compound Z is, so when dilute NaOH is used with the aldehyde, then it is called as aldol condensation. So here the acetaldehyde, which is the ethanol, it undergoes aldol condensation in the presence of dilute alcohol, in the presence of dilute alkali to form aldol. Since this compound Z is called aldol, which is a monohydroxy aldehyde. So its actual IUPAC name is 1234, which is 3-hydroxy 3-hydroxy butanol. So which is also called aldol. Option A is the correct answer. Then the compound which is not formed during the dry distillation of a mixture of calcium formate. Compounds which are not formed during the dry distillation of a mixture of calcium formate, which is HCOO whole twice Ca. It is called calcium formate, and calcium acetate, which is CH3COO whole twice Ca. It is called calcium acetate. So when there is the dry distillation of calcium formate, then it will form HCHO and calcium carbonate, CSU3. So it will form methanol or formaldehyde. Formaldehyde it will form. And and by the dry distillation of calcium acetate, it will form CH3CO CH3, which is propanol. No, it will form propanone or acid. Yeah, propanone will be formed and calcium carbonate will be formed. So the compound which is not formed, so propanol, uh, so when they both are heated, then it can form an HCOO whole twice Ca, which is the calcium formate, and calcium acetate. When they both are heated, then it will form 2 moles of ethanol. Ethanol will be formed, and CaCO3. So here it means that ethanol is formed, uh, propanone is formed, and methanol is also formed, but propanol is not formed. So propanol, which is CH3CH2CHO, which is propanol, this is not formed. So option A is the correct answer. Then it is told that an organic compound X is oxidized by using acidified potassium dichromate. So K2Cr2O7, which is called potassium dichromate. So it is acidified, so H plus is used. So when this organic compound X is oxidized, um, it will give nascent oxygen. Uh, the product obtained, let's say Y, that reacts with phenyl hydrazine. It reacts with, that is C6H5 NH NH2, which is called phenyl hydrazine. So this compound Y, it reacts with this phenyl hydrazine to give uh, yeah, reacts with phenyl hydrazine, and it does not answer silver mirror test. It means that this product Y which is formed, it does not react with Tollens reagent. It will not react with Tollens reagent. So here silver mirror is not formed. So then here the possible structure of X is, so it reacts with phenyl hydrazine. It means the product Y, it should contain the ketone group. It should contain the ketone group, and the same product, it does not give silver mirror test. It means that it should be a ketone only, and it can't be aldehyde, and it can't be aldehyde. Since why? The rule is that aldehydes will give silver mirror test. It will give silver mirror test, but the ketone will not give silver mirror test. So hence the product Y have should be a ketone. So it means that only in the option A it is a ketone, and in option C it is aldehyde. So CH3COCH3 only is the required compound X, since it is only, since why it is the only ketone out of all these four options. So option A is the correct answer. No, sorry. Here it means the compound Y should be a ketone. Y should be the ketone, which is CH3COCH3. So it means that on the oxidation of this compound X, the compound Y is produced. So it means that the compound X should be a 2-degree alcohol. Should be a 2-degree alcohol. It means that it should be CHOH, CH3, CH3. And since in option B only we have we have 2-degree alcohol, and in option D it is a 1-degree alcohol. So uh, D can't be the answer. So option B only is the correct answer, since it is the only 2-degree or secondary alcohol. Then it is told that the reaction involved in the oil of wintergreen test is salicylic acid. Salicylic acid, that is salicylic acid is which is orthohydroxy benzoic acid, is OHCOH, which is called salicylic acid. So on heating with concentrated H2SO4, uh, there will be dehydration reaction. It means that it will remove one molecule of H2O, then it will form mm, in the oil of wintergreen test. Here some product will be formed here. Then it is told that the product, it is treated with sodium carbonate solution. Then the missing reagent in the above reaction is, it means that here one more reactant should be present. So what is the other reactant A that we have to find out? So the esterification, so in the oil of wintergreen test, so the oil of wintergreen, it means what? Oil of wintergreen, it means that it is called methyl salicylate. Methyl salicylate. Methyl salicylate, which means that it is OH COOCH3. It is called methyl salicylate, and it is also called the oil of wintergreen. So if the oil of wintergreen, which is an ester, if it has to be formed, then this salicylic acid should be uh, reacted with m- methanol. We should react it with methanol, which is CH3OH. Then only this methyl salicylate and H2O will be formed, and this is called oil of wintergreen test. So we should have an esterification reaction of methanol with salicylic acid, then only this oil of wintergreen will be formed, which is called as the oil of wintergreen test. So we should add m- methanol. Methanol should be added. So option C is the correct answer. Then it is told the compound which forms acetaldehyde when heated with dilute NaOH. So the compound which forms acetaldehyde, it means acetaldehyde, which is CH3CHO, which is also called ethanol. So the compound which forms when this acetaldehyde is heated with dilute NaOH, then it will form, okay, the compound which forms acetaldehyde when heated with dilute NaOH. It means that with some compound X, when it is heated with dilute NaOH, then it forms acetaldehyde. Then what should be that compound? It has been asked. So the rule is that ald aldehydes, aldehydes, which is RCHO, that are formed by alkaline hydrolysis, by the alkaline hydrolysis of geminal dihalides, it means that on the same carbon the two halogens should be attached, then they are called as geminal dihalides. So when there is alkaline hydrolysis of geminal dihalides, and this carbon should be the terminal carbon also, it means it should be at the end of the carbon chain, then only mm, this reaction will give this reaction will mm, give geminal diols. Will give geminal diols. It means that these two halogens will be replaced by OH groups. And which will react with NaOH in the presence of heat. It will form RCHO. It means it will form aldehydes through the uh, removal of one H2O. So it means that we should have geminal dihalides and it is forming CH3CHO. It means the alkyl group should be CH3. Therefore, if CH3CHO is formed, it means that when on heating in the presence of dilute NaOH, so it means that it should be formed from geminal diols, which is CH3, CH, OH, and OH, and which will be formed from the alkaline hydrolysis of geminal dihalide. So it should be CH3, CH, X, and X. So it should be, so the compound, here we can write it, the compound A. So so this compound A from which the acetaldehyde is obtained on the reaction of dilute NaOH. Now that should be 1,1 dihalo 1,1 dihaloethane 1,1 dihaloethane. So it should be 1,1 dichloroethane. So we we can take 1,1 dichloroethane dichl dichloroethane. So option D is the correct answer. Then here it is told the compound obtained when acetaldehyde CaCCHO reacts with dilute aqueous sodium hydroxide with dilute NaOH solution, then the compound which is obtained, that will be this one, CH3, then OH, then CH2CHO, this is H. So here, so on this carbon, the four groups which are attached, they all are uh, different. So it means that it is a chiral carbon or asymmetric carbon. So it will show optical isomerism. So it will show optical isomerism, and geometrical isomerism it can't show, since why it has no double bond. So here this one which is so it is 3 hydroxy butanol 3 hydroxy butanol, which is also called as aldol. So it means that this aldehyde, so here the rule is that aldehyde undergoes aldol condensation Aldol condensation means this acetaldehyde, it undergoes aldol condensation in the presence of dilute alkali to form aldol. This aldol is, its IUPAC name is 3-hydroxybutanol. So here we have one asymmetric carbon alkyl or chiral carbon. So we can have the D and L forms. So it means that it will show optical isomerism only. So option B is the correct answer. Then it is told the correct sequence of steps involved in the mechanism of Canizaro's reaction is. The correct sequence of steps involved in the mechanism of Canizaro's reaction. So in Canizaro's reaction, the steps are, so so if you have formaldehyde, here the nucleophile which is OH minus, it will attack here, and this pi electrons will shift on the oxygen atom, and and so it is a fast step. So the step 1 is fast. So here it will form CH, OH and O minus, and then it will react with another HCHO, which is formaldehyde. Now these sigma electrons of hydrogen will attack here on this carbon, and these pi electrons will shift on the oxygen atom, and these lone pair will shift here, and then mm, so it means that from here we will form, here it will form mm, CO, C, double bond O, OH and H, then it will attack on HCO minus H, okay. So uh, uh, so finally it will form. So here there will be the transfer of the hydride ion, transfer of the hydride ion. So here it will form C, H, 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 O minus plus H, C, OH, double bond O. And then finally it will form, finally one H plus will be added, and then it will form C, H, H, OH. it means CH3OH will be formed. So the first step first step is attack nucleophilic attack, which is a very fast step. And then we have transfer of hydrogen, and then here we have transfer of H plus N. In the second step we have transfer of hydrogen, and third step we have transfer of H plus N. So option A is the correct answer. Then here we have benzaldehyde and acetone can be best distinguished using benzaldehyde. It means that we have benzaldehyde is PHCHO. It's called benzaldehyde. And acetone is CH3CO CH3, which is called the acetone. So benzaldehyde and acetone can be best distinguished using so the answer is Tollens reagent. Since why? Mm, benzaldehyde, it is a weak reducing agent. It is a weak reducing agent. So it can reduce. So it can reduce the Felling's solution, which is ammonical silver nitrate solution. Ammonical silver nitrate solution is NH4OH and HNO3. So it reduces the ammonical silver nitrate solution to give silver mirror. Silver mirror it will give, and it will give uh, benzoic acid. From AgNO3 and NH4OH, we will obtain the silver oxide, which will react with the benzaldehyde to form silver as the precipitate. So it will give silver mirror, and AgNO3 with NH4OH, it is called the Tollens reagent. So acetone is not a weak reducing agent. So since benzaldehyde is a weak reducing agent, so it can be oxidized to carboxylic acid. So it can be oxidized, but here the acetone is not easily oxidized. The acetone is not easily oxidized with the Tollens reagent, so it will not give the Tollens test. So hence option D is the correct answer. So by Tollens reagent only we can distinguish in between benzaldehyde and acetone. Then it is told formic acid is stronger than acetic acid. Formic acid Formic acid, it means that it is HCOOH, and acetic acid means CH3COH. Now it is told that formic acid is more stronger than acetic acid. Since why here we have one CH3, we have one methyl group which is attached to the COH group and which has the plus I effect, which is the positive inductive effect. But here in case of HCOH, here there is no methyl or no alkyl group which is attached. So it means that here this hydrogen is more acidic than the hydrogen in the a- acetic acid. So it means it can be more easily explained by using the plus I effect. So option C is the correct answer. Then it is told that the reagent with which both acetaldehyde and acetone react is, so acetaldehyde, which is CH3CHO, acetaldehyde, and acetone, which is CH3COCH3, the acetone. So the reagent with which both will react, so that will be uh, the alkaline solution of iodine, which is called the iodoform test. So they both will give iodoform test, which is the alkaline solution of iodine. Since why the with iodine, acetone and acetaldehyde both will give iodoform as the product. So with CH3CHO also, it will react with iodine in the presence of NaOH and it will form CHI3, which is called iodoform and which forms a yellow precipitate. And with acetone also, which is CaCO CH3, with acetone also, it will give CHI3, which is the yellow precipitate. Since why the reason is that those compounds which have the CH3CO group, here both the acetaldehyde and acetone, they both has the CH3CO group, so they both can give the iodoform test. They both can give the iodoform test. So it means option B is the correct answer. Then it is told that which of the following gives an aldehyde on dry distillation. Which of the following gives an aldehyde on dry distillation? So dry distillation of, so calcium formate is HCO whole 2Ca, which is calcium formate, and calcium acetate, which is CH3COO whole twice Ca, and calcium benzoate, which is C6H5 benzoate, which is C6H5 COO whole twice Ca, which is calcium benzoate. So now when calcium formate and and calcium acetate, they will undergo dry uh, distillation. When they will undergo dry distillation, then it will form CH3CHO, which is acetaldehyde. Acetaldehyde. And when only calcium, if only calcium acetate is used, if only calcium, if only calcium acetate is, it undergoes dry distillation, then it will form CH3COCH3, which is the propanone or acetone. So it is a ketone, which is not an aldehyde. And when only calcium benzoate is used, then it will form C6H5, C6H5COC6H5. It means that it will form diphenyl ketone. Diphenyl ketone it will form. So so here also aldehyde is not formed. And when calcium acetate and calcium benzoate is used, calcium when calcium when calcium acetate, which is CH3CO whole twice Ca, calcium acetate and calcium benzoate is used, then on dry uh, distillation, it will form C6H5COCH3. So here also uh, a ketone will be formed here. Here also methyl phenyl ketone will be formed. Methyl phenyl ketone will be formed. So here also aldehyde is not formed. So it means that aldehyde will be formed only when we have the uh, same number of moles of calcium formate and calcium acetate. So option A is the correct answer. So here it is told that oil of wintergreen is. So oil of wintergreen means it is methyl salicylate, methyl salicylate, which is which is obtained from salicylic acid, which is phenol with COOCH3. So it is called methyl salicylate. Since why this one means orthohydroxybenzoic acid, it is called as salicylic acid. Salicylic acid. Salicylic acid. So the methyl salicylate is called as the oil of wintergreen. Oil of wintergreen. So obviously it is an organic ester. So it is an organic ester. So option A is the correct answer. Then it is told an organic compound A, it burns with a sooty flame. An organic compound A, it burns with a sooty flame. Uh, so it burns with oxygen with a sooty flame, and it is negative towards Tollens reagent test. It has negative Tollens test, and positive Bosch reagent test. Positive Bosch reagent test. So since it burns with a sooty flame, so which is so it is an ignition test. So in the ignition test, it gives sooty flame. It means that that it is an aromatic compound. It is an aromatic compound, and it gives negative Tollens test. It means that it has no aldehydes. So here we have absence of aldehyde CHO group, and it gives positive Bohr's reagent test. It means that um, it has the ketone group. It has ketone means RCOO R dash group. So it means that the compound A, it is an aromatic ketone. It is an aromatic ketone. So here we have to see which of these options are aromatic ketones. Now in option A, it is benzaldehyde, which is CHO. So it has aldehyde group. So A can't be the option. Since it gives negative Tollens test, it means that any aldehyde group is absent. Aldehyde group is not there here. So it can't be benzaldehyde. And then in option B, it is told it is acetophenone. Acetophenone, which is CH3CO and the benzene ring. So it is acetophenone. Acetophenone it is called. So it is an aromatic ketone. And acetone is CH3COCH3, which is a ketone, but it is not an aromatic compound. And salicylic acid is this. Salicylic acid is so it is orthohydroxybenzoic acid. It is salicylic acid. So here ketone group is absent. So hence it can't give the Bosch reagent test. It can't give positive Bosch reagent test. Hence it should be acetophenone only. So option B is the correct answer. Then it is told that HCHO was treated with reagent X. HCHO means the formaldehyde. So formaldehyde was treated with a reagent X. Then the product which is formed upon hydrolysis in the presence of an acid gave CH2 C2H5OH. Then the reagent X is. So it is treated with reagent X. So here the product. So the reagent is the Grignard reagent, which is RMGX, and here the alkyl group is the methyl group. So when CH3MgI that is reacted with HCHO, then it will, in the presence of dry ether and in acidic solution, then produce um, it will produce 1 degree alcohol. CH3 CH2OH it will form, which is the ethanol. So the product formed upon hydrolysis in the presence of an acid. So it means the reagent X should be CH3MgI. So option D is the correct answer, which is obviously a Grignard reagent. Since why Grignard reagent only on reaction with aldehydes, it will give primary alcohols. It will give primary alcohols. Then here it is told that the relative acidic strengths of benzoic acid. So benzoic acid is COH, and then orthotoluic acid, toluene is CH3, so it is orthotoluic acid, and then we have paratoluic acid. So this one is orthotoluic acid, and this is paratoluic acid. It means here CH3 and here COH. So this will be called as paratoluic acid, and this is benzoic acid. So here we have to find the decreasing order of the relative acidic strengths. So when the methyl group is attached, when CH3 group is attached, here we have plus I effect, which is the positive inductive effect. So it will increase the e- electron density in the ortho and in the para positions. So the methyl group, CH3 group, it will increase the electron density throughout the benzene ring. It will increase the electron density throughout the benzene ring. So hence, when methyl group is attached, it will decrease the acidic strength. So it will decrease the acidic strength. It will decrease the acidic strength of the benzoic acid. And when and when this methyl group is attached more closer to the COH group, it will more decrease the acidic strength. So hence here the benzoic acid is the most acidic. So benzoic, okay. So here there is one rule which is called as the ortho effect. It's called, there is something called the ortho effect. Ortho effect, it means that ortho substituted ortho substituted benzoic acids are more stronger acids than benzoic acids. Ortho substituted benzoic acids are more stronger than are stronger than benzoic acids, which is called as the ortho effect. So hence the orthotoluic acid is the most acidic. Then we have benzoic acid, and since the methyl group has the positive inductive effect, so hence it will increase the electron density of the benzene ring, and hence it will decrease the acidic strength. So hence this paratoluic acid is the least acidic. So paratoluic acid is less acidic than benzoic acid also. So this is the required order. So it means that option D is the correct answer. Then it is told that when formic acid is heated with concentrated H2SO4, the gas evolved is. when formic acid means HCOOH. When formic acid it is heated with concentrated H2SO4, then the gas evolved is, so here it will form CO2, so it will form CO plus H2O. So carbon monoxide gas will be evolved. So CO, only CO gas will be evolved. So option B is the correct answer. Then it is told the reagent used to distinguish in between acetaldehyde and benzaldehyde is. So acetaldehyde is CH3CHO is the acetaldehyde, and benzaldehyde is BHCHO. This is benzaldehyde. Now here it is told which reagent should be used to distinguish in between these two aldehydes. So here, if Felling's solution is used, then benzaldehyde will not respond to the Felling solution test. So it will not respond to the Felling solution test, and acetaldehyde will give positive Felling's test. Will give positive Felling's test. Since why? If we have uh, aliphatic aldehydes, if you have RCHO, it means where R is some alkyl group. So here we have aliphatic aldehydes. So for aliphatic aldehydes, they will react with CuOH whole twice in the presence of NaOH. So which is called as the Felling's solution. So then it will give RCONA plus Cu2O plus H2O. So here it will give cuprous oxide, which forms a red precipitate. Cuprous oxide will form a red precipitate. So it means that acetaldehyde will give positive Felling solutions test, and benzaldehyde will not respond to Felling's solution test it, uh, since it has alkaline nature. So hence option B is the correct answer. Then it is told iodoform reaction is answered by all except. So the rule is that mm, 2 degree and 1 degree a- um, alcohols, 1 degree and 2 degree alcohols, and carbonyl compounds having the CH3CO group gives the iodoform test. It gives the iodoform test. Now, 1 degree alcohol, it means that it should be of the form RCH2OH. It is a 1 degree alcohol, or it can be a 2 degree alcohol also. It can be of the form RCH R dash OH. It can be a 2 degree alcohol, and here this R dash, this alkyl group, it um, can be any alkyl group also, or it can be any aryl group also. So it means 2-degree alcohols and 1-degree alcohols can give the iodoform test. Now, iodoform solution, iodoform in the iodoform test, the solution which is used, it is the I2 with NaOH. So hence here, as you can see, that the first one has got 2-degree alcohol. Option B has aldehyde, which has the CH3CO group. So option B has, so it will give iodoform test, and the C and D also it will give iodoform test since they are 1-degree alcohols. C and D both are 1-degree alcohols, so they will give iodoform test. But in the case of option A, here okay. Now it means that okay, okay. So the rule is that all 1-degree alcohols and 2-degree alcohols will not give iodoform test. It means that at the end it should either have CH3CO, or at the end it should have CH3CHOH group, and here it can be any alkyl group. So this part is wrong actually. Not all alcohols. So only these type of alcohols which is having CH3OH, CH3CHOH at the end, and this one, this R dash, it can be alkyl group or aryl group. So at the end it should have CH3CHOH group, or at the end it should have, at the end it means that at the end of the carbon chain, at the end of the carbon chain it should have either CH3CHOH group or CH3CO group, then only it will give iodoform test. So it means that in the option A it has CH3CHOH at the end, so hence it will give iodoform test. But in the option D, in option C, of course, it has CH3CHOH at the end of the chain. Here it is H. And only in the option D, we don't have CH3CHOH at the end of the chain. So hence it will not give the iodoform test. So option D is the correct answer. Then here it is told that C6H5COH, which is the benzoic acid, on reaction with NH3 and with heat, that will form the compound P. Now the compound P is um, benzamide, CONH2. This is benzoic acid. So from benzoic acid, if it is heated in the presence of NH3, then it will produce benzamide, which is the compound P, and then which is uh, reacted with NaOBr, then it will produce um, benzamine, will produce benzamine, or it is called aniline. Aniline it will form, which is the compound Q. And when it is heated with concentrated H2SO4, it is heated to 460 degree 460 Kelvin, then it will produce mm, then it will produce sulfonalic acid, which means here we have the amine is NH2 and SO3H. So sulfonalic acid, so it is like this. Here we will have NH2 group and here we will have SO3H. So it is called the sulfonalic acid. It will be formed, which is actually para amino um, benzene sulfonic acid, which is also called sulfonalic acid. So option C is the correct answers. Since why it is the compound R which is formed. Option C is the answer. Then here it is told that match the reactant in column 1 with the reaction in column 2. So here when acetic acid CH3COH, when yeah, when it reacts with Cl2 in the presence of red phosphorus, then it is called HVZ reaction, since it will form alpha monochloroacetic acid is CH2 Cl CH2 Cl COH, which is alpha monochloroacetic acid. It will form and it will give HCl. And then when alpha monochloroacetic acid is further reacted with red phosphorus, then finally after one more step it will form trichloroacetic acid is Cl. Okay, the Cl Cl and Cl COH plus HCl, so it will form alpha 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 trichloroacetic acid will form. So it is a HVZ reaction. So option 1 will match with C. So the first one will match with C, and then sodium phenate. Second one is sodium phenate, which is like this, ONA. It's called sodium phenate. So that will react with CO2 to produce OCOONA. So it is sodium phenyl carbonate. It's called sodium phenyl carbonate. So which is called as a coal base reaction. Coal base reaction. and then there will be rearrangement. There will be rearrangement to form sodium salicylate, CONA and OH. So it is sodium salicylate. Since why it is obtained from salicylic acid. Then if it is hydrolyzed in the presence of an acid, then it will produce salicylic acid. It will produce salicylic acid, which is called the Kolbe's reaction. So it means that the second one will match with D. So first one matches with C, second one matches with D. It means option D is the correct answer. Or we can also see the third case, which is methyl cyanide. So now methyl cyanide, which is CH3CN, that will react with in the presence of SnCl2 with HCl, which is called as the Stephens reaction. Stephens reaction, then it will form CH3CH NH NH2, okay, CH3 NH2Cl, and then when it is hydrolyzed, then it will form CH3 CHO and NH4Cl. So it is called the Stephens reaction. So the second one will, the third one will match with A obviously, and the toluene fourth one will match with B, which is the Friedel-Crafts reaction, which is this is the toluene, which is methyl benzene. Toluene will react with chloromethane with methyl chloride to form with anhydrous aluminum chloride AlCl3, and heat. It will produce orthoxylene, which is orthomethyl toluene, and it will produce paraxylene also, CH3, which is called paraxylene. So which is called as the Friedel-Crafts reaction. So hence it means that the option D is the correct answer. Then it is told that the acidic strength of active methylene group is the acidic strength of active methylene group N, these three, decreases as. So we have to find the decreasing order of the acidic strength of the methylene group here. So the rule is that an active methylene compound, an active methylene compound, the methylene group, which is the CH2 group, it exists in between the strong electron withdrawing groups. So if in the active methylene compound, the methylene group exists in between strong electron withdrawing groups, electron withdrawing groups. Then it will increase the acidity of the methylene group. Then it increases the acidic strength, increases the acidic strength of the methylene group. So in the first one, we have CH3CO, CH3CO, CH2, and here we have COO, C2H5. It means CH2, CH3. And in the second one, we have CH3CO, CH2, then COCH3. Then in the third one, we have C2H5 means CH3, CH2, OOC, okay, OCO, CH2, COO, C2H5, CH2, CH3. Okay. So here, the rule is that esters are less acidic than ketones. Esters are less acidic. So for esters, the methylene group is less acidic than the methylene group in ketones. Since why? In case of esters, since why the enolate ion, the enolate ion which is formed from an ester, it will be less stable than that which is produced from the ketone. The enolate ion that is produced from the ester is less stable than in case of ketone. So hence this ester, it is less in this methylene group, it is less acidic than in case of ketone here. So since here the both the groups are ketone only here, so the second one is, so it is the most acidic here. And here we have one ketone group and one ester group, so it is less acidic than the second one. And in the third one, here both the groups a- a- attached to the methylene group. Here both the groups which are attached to the methylene group, they are esters only, so it is the least acidic. So hence the order of the acidic strength, it is second one more than the first one, more than the third one. So 213. 213. So option C is the correct answer. So here it is told that X, the compound X on ozonolysis, means on reductive ozonolysis, it gives the compounds Y and Z, and Y can be also obtained by Etard's reaction. By Etard's reaction also it can be obtained, and Z undergoes disproportionation reaction with concentrated al alkali. Y undergoes disproportionation disproportionation reaction with concentrated alkali. Then we have to find the compound X. So here the reaction is, here actually we have to use the vinyl benzene, or it is styrene. So if I use vinyl benzene or benzene or styrene, then on ozonolysis, it means it reacts with ozone, O3, then one ozonide will be formed, this CHO, CH2, OO, which is the ozonide, and here um, it will separate here, from here it will separate, and in the presence of zinc and H2O, here then it will form HCHO. From here it will form HCHO, which is formaldehyde, and it will form zinc oxide, and it will form the benzaldehyde, CHO, benzaldehyde. So here the benzaldehyde is the compound Y, and the formaldehyde is the compound Z. Since why? When the benzaldehyde can be also obtained from the Itard's reaction. Now the Itard's reaction, it means that here toluene will react with CrO2 Cl2 in presence of CCl4 and H2O. It will form benzaldehyde. So it means that the compound Y can be obtained from toluene, and Z will undergo disproportionation reaction with concentrated alkali. Since why? Here the okay, this HCHO on reaction with NaOH, that will form HCOO Na, which is sodium formate, and CH3OH. So it will undergo disproportionation reaction. So hence the compound X should be vinyl benzene or styrene. Vinyl benzene or styrene, which is option B. So option B is the correct answer. Then here it is told, when CH2CHOCH2CH3, it reacts with 1 mole of HI, then one of the products formed is. So when it reacts with HI, uh, then it will form CH2 CHOH plus CH3 CH2I. Since why the carbocation will be formed here and O minus will formed here when there will be heterolytic cleavage here. So then H plus will go with this part and I minus will attack here, and then it will form CH3 CH2I and CH2 CHOH. So it will form vinyl alcohol. Okay, so it will form Vinyl alcohol and iodoethane. Iodoethane. So iodoethane will be formed, vinyl alcohol will be formed, which is okay. And this vinyl alcohol, it will show tautomerism. It will show tautomerism. It means it will show enol, uh, means keto enol tautomerism. It will show. It means that one of the isomers will be one of the isomers. It will be CH3CHO for this one. Since why here this one, this bond can uh, this H plus can come out, and this one can go here, and this H plus can again come here. Okay. So it means that ketoenol tautomerism it can show. So with vinyl al alcohol, the ethanol will also be formed. So ethanol can be formed, iodo iodoethane can be formed. So ethanol is one of the products that can be formed. So option D is the correct answer. Then acetophenone cannot be prepared easily from. Now acetophenone is like this, CH3CO and here one benzene ring. So acetophenone cannot be prepared easily starting from toluene. It can't be prepared easily from toluene, which is CH3. As CH3 cannot be is acetophenone cannot be easily prepared from toluene. As CH3 group cannot be easily okay. So from toluene we can't obtain this acetophenone. Since why here the CH3 group it can't be easily converted to the COCH3 group. It can't be easily, the CH3 group can't be easily converted to this group, to COCH3 group. So hence um, toluene can't be used. So option B is the correct answer. Then it is told that the formation of cyanohydrin from a ketone is an example of the formation of cyanohydrin from a ketone is an example of. Okay. So in the previous one, from methyl phenyl carb carbinol, which is C6H5 CHOH CH3, which is methyl phenyl carbinol. Here if we use the, if it is oxidized using K2Cr2O7, So it means it will give nascent oxygen. Then it will form acetophenone, COCH3. Acetophenone will be formed here. And also the option B, from toluene also we can obtain, but it will be slightly, it will take like steps. Three steps are required here. C6H5CH3, then with chromyl chloride, CrO2 Cl2. With chromyl chloride it will give nascent oxygen, then it will be oxidized to the aldehyde, which is benzaldehyde. Then it will react with CH3MgBr, which is the Grignard reagent. In the presence of H2OH plus, it will form C6H5, then CHOH CH3. Then it is further oxidized to produce acetophenone. Acetophenone. So it requires three steps, so it is not very easy. Since here in the first one, in the option A, it takes only a single step to convert this methyl phenyl carbinol into the acetophenone. And in the second case, it requires three steps to convert this toluene into acetophenone. So it is not very easy to convert. And in the third case, in the option C, here C6H5CH, C6H5 triple bond CH, C triple bond CH, which is the phenyl acetylene, I can say phenyl acetylene. So when it is hydrolyzed in the presence of an acid, then it will form C6H5 COH CH2, which is the enol will be formed, and it's, so it will show tautomerism. Tautomerism it will show, which is so its tautomer is acetophenone. Acetophenone will be formed, which is a ketone. And in the option D, the benzene, when it reacts with CH3COCl in the presence of anhydrous AlCl3, then it will form acetophenone. So here also it will take a single step only. So in all the options A, C, and D, the acetophenone is formed from a single step only, but only in the case of option B, it takes three steps to convert this toluene into acetophenone. So hence option B is the correct answer. Then here it is told the formation of cyanohydrine from ketone is an example of. So formation of cyanohydrine is like this. It means that here we have two alkyl groups attached with the same carbon, and in the same carbon we have alcohol group and the cyano group. So then it is called as cyanohydrine. So cyanohydrine is formed from a ketone. So it is formed by the nucleophilic substitution of the nucleophile cyanide with a ketone. So the nucleophilic substitution of a ketone with the cyanide nucleophile, the cyanide nucleophile. So here what will be, how will be the reaction here? Here the two alkyl groups, here we have the ketone. So here we have, on the carbon we have a partial positive charge, and on the oxygen we have partial negative charge. Since oxygen is more electronegative than carbon, then the cyanide nucleophile will attack on this carbon, then so it will be a reversible reaction, and then it will form uh, a transition state will be formed, which is O. So this one will go here. These pi electrons will go on the oxygen atom, and then it will form Cn R dash R. Then in the presence of H plus ion, which can be obtained from H2O or from HCN, it will form cyanohydrin, which is RCR dash OHCN. So it is an example of nucleophilic substitution reaction. No, or I can say nucleophilic addition. Sorry, it is not nucleophilic substitution. It is nucleophilic addition, nucleophilic addition reaction of a ketone with the cyanide nucleophile. So option A is the correct answer.